students, welcome again to my channel DNA.12 Education. Students, today we are going to discuss a new topic in mathematics. The topic is about probability. This video is presented by DNA.12 Education. Okay, students, probability for independent and dependent probability. Okay, students, directly go to the next topic. Independent probability. An independent event is an event in which the outcome is affected by another event. If A and B are independent events, the probability of both events occurring is the product of the probabilities of the individual events. Probability of A and B is defined as probability A times probability B. Probability A and B equal probability A times probability B. So, independent event is the product of the probabilities of the individual events. Clear, everyone? Okay, students, go to the independent probability example. For example, a box contains 4 red marbles, 2 green marbles, and 3 blue marbles. 1 marble is removed from the box and then replaced. What is the probability that the first marble is blue and the second marble is green? The question is, what is the probability that the first marble is blue and the second marble is green? Okay, students. Let's say this one is a box. This box contains 4 red marbles, 2 green marbles, and 3 blue marbles. We can define for the first pick is red, green, and blue. And continue to the second pick. Look at the diagram. There will be 3 combinations to every red, respectively. We'll find red, green, blue. For red, green, blue for green, and red, green, blue for blue. Alright? So we can find for the first pick, the probability of red is 4/9. For green, 2/9. And B, 3/9. And for the second pick, because 1 marble is removed from the box and then replaced, so the probability of red for the second pick is 4/9. For green, 2/9. And blue, 3/9. And related to green, for the second pick for red, 4/9. Green, 2/9. And blue, 3/9. And the last related to blue marbles, for red, 4/9, green, 2/9, and blue, 3/9. Students, this case, 1 marble is removed from the box and then replaced. So the composition is still constant, no change. Based on this diagram, we'll find the outcome. Red, red green, red blue, green red, green green, green blue, blue red, blue green, and blue blue. Overall, we have 9 outcomes. The question is, probability of the first marble is blue and the second marble is green. So we can define probability blue and green equal probability of blue marbles times probability of green marbles equal 3/9 times 2/9. We found 6/8 too much. Alright? Because the first marble replaced the size of the sample size for the first 9 does not change from the first drawing to the second, 9. So we can take this conclusion. We can conclude that the events are independent. The characteristic of the independent probability is replacement. Okay, students, I think it's very clear. Now we go to dependent probability. A dependent event is affected by the outcome of a second event. A dependent event is affected by the outcome of the second event. Two events are dependent if the result of the first event affects the outcome of the second event, so that the probability is changed. Once again, the probability is changed because both events are affected each other. If A and B are dependent events, the probability of both events occurring is the product of the probabilities of the individual event. So the probability A and B is defined as probability A times probability B. Generally, we can define probability A and B is probability A times probability B given on probability A. Okay, this is the meaning of B plus A. Means the probability of event B given A. Dependent probability commonly and conditional probability. Okay, so then, dependent probability. Take a look to the example. A box contains 4 red marbles, 2 green marbles, and 3 blue marbles. One marble is removed from the box and then node replaced. Once again, node replaced. What is the probability that the first marble is blue and the second marble is green? Okay, let's say this one is a box contains 4 red marbles, 2 green marbles, and 3 blue marbles. For the first pick, we'll find red, green, and blue respectively. And then we'll find the connection to red, green, and blue respectively. We'll find red, green, blue, red, green, blue, red, green, blue respectively. The probability for the first pick of red is 4/9, green 2/9, and blue 3/9. That's very clear. Soon, one marble is removed from the box and then not replaced. Not replaced. For the first diagram for red, one red already taken. So means 3 red marbles left, 2 green marbles, and 3 blue marbles. And we'll find for the second pick, red is 3/8, green 2/8, and blue 3/8. For the second diagram, we took green for the first pick. Mean the composition, the new composition for the second diagram is 1 green, 4 red, and 3 blue. So the probability for the second pick is 4 over 8 for red, 1 over 8 for green, and 3 over 8 for blue. Now for the second branch. For blue, for the first pick is blue. Now we have a new composition. 2 blue marbles, 4 red marbles, and 2 green marbles. Now we can go to the second pick. For red, 4 over 8, green, 2 over 8, and blue, 2 over 8. Students, one marble is removed from the box and then replaced. So the outcomes is red, red green, red blue, green red, green green, green blue, and blue red, blue green, and blue blue. Probability of the first marble is blue and the second marble is green. Students, what is it? This case is not replaced. Probability of blue and green equal to probability blue times probability green. Or specifically, probability blue times probability of green given on blue. So the probability of blue and green is 3 over 9 times 2 over 8 equals 6 over 72. Is it clear, everyone? I want to show you the way to find probability blue and green. So then, for the first pick is here, blue. Okay, we got 3 over 9. But for the second pick, it's green. So this is the way, right? So we have probability 2 over 8. So this is the way of dependent probability. Blue, green. Now we have 6 over 72. The other one? Because the first marble not replaced, the size of the sample size 9 is changed to the second marble is 8. So we can take the conclusion is the events are dependent probability. The correct characteristic of probability, dependent probability, is not replaced. So then, the characteristic of the dependent probability is not replaced. The characteristic of dependent probability is not replaced. Clear, everyone? Okay, thank you. Go to the next example. Exercise 1, dependent probability. Example. A card is chosen at random from a standard deck of 52 playing cards without replacing it. A second card is chosen. What is the probability that the first card is chosen is a queen and the second card is a jack? Students, let's answer this question together. Students, as you know, playing card consists of 52 cards. king, queen, jack, ace, and number 1 until number 10. Totally, overall is 52 cards. Right? King consists of 4 cards, queen 4 cards, jack 4 cards, and ace 4 cards. Right? The question is the probability of the first card chosen is queen and the second card is jack without replacing it. This case is without replacing, right? So the probability of queen and jack for the second pick equal probability of queen times probability of queen plus jack means probability of times probability of jack plus queen. The meaning of probability jack plus queen is probability of jack given on probability queen. Okay, for the first pick, probability for the first pick, probability of queen is 4 over 52. Alright? Why over? How comes? Because queen consists of 4 cards. Right? Clear? Okay, the question is without replacing. So we can take the conclusion. This case is dependent probability. When one queen card is taken, now we have a new composition. We have 51 cards left. Okay, 51 cards left. Right? So the probability of jack automatically jack is 4. The probability of jack is 4 over 51. Okay, so that's clear. So the probability of queen for the first pick and jack for the second pick is 4 over 52 times probability jack given on queen 4 over 51. Now the final answer is 4 over 666. Is it clear, everyone? Okay, go to the next exercise. Exercise 2, dependent probability. 4 cards are chosen at random from a deck of 52 cards without replacement. What is the probability of choosing a 10, a 9, an 8, and a 7 in order? Okay, so then this question is very easy, right? As you know, there are 52 cards. Okay, there are 52 cards, all playing cards. 52 cards consist of 4 king, 4 queen, 4 jack, 4 ace. And then the last is number card. The number card is number 2 until number 10. Okay, this is the number class, right? Number class. Okay, so then the question is the probability without replacement. Okay. Okay, student. For the first case, is a 10. Okay. So the probability of 10 is how many 10? 4 over total is 52. Right? How do you know that there are 4 10 cards? Every single, as you know that 52 cards consists of 4 groups. Right? Club, diamond, heart, and spade, right? So every single of item consists of 4 cards of number 10. So that's why the probability of 10 is 4 of 52. Now is the second pick. For the second pick is a 9. As you know, now we have 51 cards left. Right? So the probability of 9, okay, 4 over 51. 01? Okay. Next, we go to the third pick. The third pick is an 8. 8, right? As you know that now we have 50 cards left. Okay, so the probability of 8, how many number 8 in every group? In every group there is 1 card, but there are 4 groups for number 8. So the probability is 4 over 50. And the last is 40. Sorry. Last is 40. The fourth pick is 7. Now we have 49 cards left. Right? So the probability of 7 equals how many cards of number 7 in 52 cards? Yes, there are 4 cards for number 7. So 4 over 49. Right? So now we're going to conclude. What is the probability overall? The probability of 10, 9, 8, and 7 equal probability of 10, probability of 9, probability of 8, and probability of 7. And right here, 4 over 52 times 4 over 51 times 4 over 50 times 4 over 49. We have 256 over 6,297,400. Okay, clear? Once again, the probability is 256 over 6,297,400. Very big, right? Okay. Is it clear, everyone? Okay. Go to the next example. Exercise 3. Dependent probability. Again, 3 cards are chosen at random from a deck of 52 cards without replacement. What is the probability of choosing 3 aces? Okay, without replacement. Okay, students, this question is very easy. Okay, without replacement. Okay, very clear, without replacement. Okay, in 52 playing cards, right? 52 playing cards. There are 4 aces, right? There are 4 aces. Without replacement, choosing 3 aces without replacement, one by one. So, again, find the probability each, right? The first page, probability of ace equals 4 over 52, right? The second page, probability of ace 2, the second ace is 3 over 51. Why 3? Because when we took one card from the beginning, now the composition is 52 cards, right? Now we go to the third thing. For the third page, okay, probability of ace 3. Our new composition for the card is 50 card left. Why 50 card left? Because for the first page and the second page, 2 cards already taken. Now we have 50 cards left, right? So the probability of ace card 3 for the third page is 2 over 50, right? The overall probability of ace 1, ace 2, and ace 3 equals probability of ace 1 times probability of ace 2 times probability of ace 3. Right? So overall, we have the answer 4 over 52 times 3 over 51 times 2 over 50. Okay? We'll find 1 over 5525. Very clear. This is the probability. Clear, everyone? Okay, next we go to the next example. Exercise 4. This is talking about dependent probability. In a sequence of 20 components, 3 are defective. Three computers are randomly selected and tested. What is the probability that all three are defective if the first and the second ones are not replaced after being tested? Students, these questions are very, very easy. Okay? Okay. We have 20 computers, right? We have 20 computers, right? But three are defective. Three defective. Okay. Now going to find the probability for three defective computers. Three defective computers. For the first case, the probability is 3/20. Okay? So means here 19 computers left. For the second page is 2/19, right? Right? Now we have 18 computers left. And the third page is 1/18. Okay, students? Okay? We took three defective computers. 3, 2, 1. 20, 19, and 18. See, number 1. So overall, the probability of the first, the second, and the third is 3/20 times 2/19 times 1/18. So we find 1/1140. The other one? Let's see it. Okay, next. Go to the next question. Okay, this is the last. Okay, Mr. Gede needs two students to help him with the science demonstration for his class of 18 girls and of boys. He randomly chooses one student who comes to the front of the room. He then chooses a second student from those still kids. What is the probability that both students are chosen from those? Students, this question is very easy. Okay, very easy. Okay. For the first, we have a new composition, right? For the first, we have a new composition. The composition is 18 girls, right? And 12 boys. Right? Okay, for the first page, this is the first page. Let's say that I'm go on board. The first. Okay? So the probability of the first page, for the first case first, the probability is 18/30, right? And for boys is 12/30, right? Is that correct, everyone? Good. Now is the second case. This is the second, right? So here is girl, boy, we're going to write or to define the probability of H. Okay. The new composition here, because one girl is taken, is 7 girl, 12 boy. And here is when one boy is taken is 11 boys, 18 girls. Right? Now you're going to find the probability. So here is 17 over 29. Here is 12 over 29. Right? And here 18 over 29. And here boys is 11 over 29. So everyone, what is the probability that both students are seasonal girls? Meaning, the meaning of this information is probability of girl for the first and girl for the second. So means probability of girl 1 times probability of girl 2 given on girl 1. Right? Okay, probability of girl 1 is this one, right? 18 over 13 and probability of girl 2 given on girl 1, so the second girl, this one, right? Girl 2. 17 over 29, right? So overall, the probability is 306 over 370. Is it clear, everyone? So the probability that both students will go is 16 over 370. Okay students, thank you for watching my YouTube channel. Hopefully all students will and you understand all the methods. Thank you very much. See you at the next one.
From John Paul School, and I will start my 7th grade this year. I've joined QPC course since January 2020 with Mr. Jasper as my course tutor. Mr. Jasper did not only teach me the proper techniques of both maths and mathematica, but he teach me how to learn independently and how to stick into a problem to find ways of solving it. The course materials were good and it's based on my school curriculum. And the mentor approaching is also good. During the pandemic of COVID-19, we studied via the internet and it's also good. And I think Mr. Jasper is very good and it's a solid course. I learned a lot. Thanks, sir.
Hai, nama saya Cassius Nathanael. Saya adalah seorang siswa kelas 6 SD Penabur Harapan Indah Bekasi. Les di Bimbel QPC sangat menyenangkan karena konsepnya fun learning. Cara mengajarnya pun asik dan tidak membosankan. Selama les di Bimbel QPC, saya menjadi lebih mudah untuk mengerjakan soal-soal matematika. Karena di sini kita akan diberikan rumus-rumus jitu yang mudah dipelajari. Oke, salam.
Halo, salam pelajar. Nama saya Pascual Clayton. Saya siswa Kolese Canisius angkatan 21. Saya di sini untuk memberi testimoni saya mengenai proses belajar saya di QPC selama masa karantina lockdown ini. Pertama, jelas belajarnya jadi lebih susah karena harus belajar online. Namun, saya berterima kasih mempunyai QPC untuk membimbing saya melewati perjalanan belajar online saya. Saya sama sekali belum familiar dengan proses belajar online. Saya sangat perlu bimbingan dan saya berterima kasih akan adanya QPC di situ untuk membimbing saya. Nilai saya pun akhirnya berhasil kekejar. Nilai saya yang 60 menjadi nilai 80 dan nilai saya yang 80 menjadi nilai 90. Itu adalah mata pelajaran IPA tuh. Jadi selama proses belajar online ini akhirnya kekejar juga nilai saya. Itu in part sangat besar karena bimbingan Sir Jasper dan QPC. Setiap malam kami belajar bersama untuk mempersiapkan diri untuk esok pagi belajar online. Jadi nilainya aman selama belajar online ini di QPC. Semuanya aman dan bahkan lebih meningkat kalau di kasus saya. Sekian dari saya, terima kasih. Salam pelajar.